Hello, good evening everyone. Am I audible to you? Hello. Hello. Right. Shall we continue? Shall we continue? Right. What we completed in the last class, Vaishnavi? What we completed, Vaishnavi? Preparations of alkynes. Alkynes, right? Right. Continuation preparation methods, right? From alkynes. Second method, method B. When alkyne treated with 2 moles of chlorine in the presence of CCl4, carbon tetrachloride, two chlorines will be added like this. Okay, 4 chlorine atoms are present in the product. This is another preparation method. Okay, am I audible, everybody? Am I audible? Right. Preparations from alkynes. Right, next, preparations from alcohols. Roman number 3. Roman number 2 is our preparation from alkynes. Roman number 3. Roman number 3 from alkynes. Sorry. From alcohols. Third preparation method, preparation from alcohols. Okay. Am I audible to you? Hello? Am I audible? Right. From alcohols. సృజన్ ఫాలో అవుతున్నారు? యా, ఓకే. నెక్స్ట్ ప్రిపరేషన్ మెథడ్, preparation from alcohols. Look at this. SOCl2, then you will get RCl, right, within the bracket, retention in configuration, retention product. Next, SOCl2 and pyridine. When SOCl2 is taken in the solvent pyridine, then you will get a alkyl halide inversion in the configuration. I'll tell you what is inversion, what is retention. Okay. Next, PCl5. See, actually, mostly we do not prefer to remember byproducts, but here you have to remember the byproducts. Clear? RCl, alkyl halide, plus POCl3 and HCl. You have to remember the byproducts also. Okay, all these are important. If you learn what are producing, that is enough. Clear? What are producing? Alkyl halide, POCl3 and HCl. Phosphoryl chloride, HCl. Phosphoryl chloride. Next, with the PCl3, RCl plus H3PO3. This is also important. What is the basicity of H3PO3? Tell me. You know, in stoichiometry you learnt about the oxyacids of phosphorus basicity. What is its basicity? Basicity is equal to 2. So dibasic acid. So SOCl2 pyridine, PCl5, PCl3, and N-hydrous zinc chloride, ZnCl2 plus HCl. This is Lucas test. Okay, Lucas reagent, Lucas test. Here we'll get alkyl halide. Okay, and one more reagent also we have, that is PBr3. In case of PBr3 also we will get a inversion product. What I given, prepare these only. Clear? Byproducts are important in this case and in this case. Okay, for remaining I'll tell you. Must and should, you should learn the byproduct here. And the byproduct in the first case, look at this all of you. SO2 plus HCl. Here also SO2 plus HCl. Right. Here you can write H3PO3. These are easy only, you can remember, but you have to work out these. RCl, POCl3, HCl, RCl, H3PO3. Okay. Right. Now my question is, so this is flow chart. We will discuss about each and every reagent. My question is, see, to get alkyl halide, whether it is alkyl chloride or bromide, we are using these many reagents, right? These many reagents. But the best reagent, which reagent is used, preferred? What is the best reagent to produce alkyl halide from alcohols? That is my question. Okay. Think. Just a second. Sir, good evening. Sir, చెప్పండి. సార్ చెప్పండి. సార్ చెప్పనా? పర్లేదు, చెప్పండి. Okay. Netherlands. Okay.
ఇంటర్మీడియట్ వాళ్ళు. సో అంటే తను ఏమనుకుంటా అంటే మీ వాళ్ళు ఒప్పుకుంటే ఒక రోజు వచ్చి మీ దగ్గర వచ్చి సెమినార్ ఇస్తాడనమాట మీ క్లాసెస్ వచ్చి. ఎవరు ఇంట్రెస్ట్ ఉంటే వాళ్ళు దే విల్ టేక్ ద డెసిషన్. ఇష్టం నీకు అర్థమైంది కదా?
ఎక్కడ? ఇంటర్ మా దగ్గర కాలేజీలోనా?
ఇంటర్.
సరేలేండి సార్, నేను చెప్తానండి, సార్ అడిగి చెప్తాను.
సరే, ఎందుకంటే నీకు మంచిగా ఒక
చెప్తాను.
చెప్పాను ఇప్పుడు. అంటే ఇప్పుడు కొంతమంది ఏంటంటే ఇంజనీరింగ్ వైపు వెళ్తారు, కొంతమంది ఇలాంటి వాటికి కూడా ఇంట్రెస్ట్ చూపిస్తారు కదా. అవును, ఎవరి ఇంట్రెస్ట్ వాళ్ళకి ఉంటుంది కదా. అనమాట. మీరు ఎంఎస్సీ ఉందా? ఎంఎస్సీ
లేవు సార్, లేవు. అవి లేవు. నేను చెప్తాను. నేను చెప్తాను.
తను వస్తాడు వచ్చి
సరే సరే
ట్రాన్స్పోర్ట్.
సరే సరేలేండి. ఓకే సార్, ఓకే ఓకే. సరే సార్, సరే సార్. రైట్. See, what is the best reagent? Can you guess, anybody? Right. See, am I audible to you? Am I audible? Hello. Bhakti? వినబడుతుందా వాయిస్ నాది? హలో హలో అదీపా, am I audible or not? వినబడుతున్న వాయిస్ నాది మీకు? హలో వినబడుతుందా ఇప్పుడు? చూడండి. హలో 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 భక్తి, హలో. ఇప్పుడు చెక్ చేయండి, వినబడుతుందా వాయిస్ నాది? హలో. ఓకే ఓకే. See, the best method for the preparation of alkyl halide from the alcohol is SOCl2. SOCl2, either this method or this method, but SOCl2. Why? Why? Can you guess? What are the byproducts here? Once look at this, SO2 and HCl. Byproducts are the gases. Byproducts are the gases. So they eliminate themselves. We no need to do any filtration like distillation, fractional distillation or distillation. Okay, they only evaporate. So we will get pure alkyl halide. We will get pure alkyl halide. But in the remaining procedures, we have to filter the byproducts. Clear? That is why preparation of alkyl halide from the SOCl2 is the best method. Best prepared method. That is also very important. Clear? Which of the following reagent is used? Best used to prepare alkyl halide from alcohol. What is that? SOCl2. Here, let us understand that word, retention, inversion. Okay, right. See the examples. Ethanol. Ethanol when treated with SOCl2. SOCl2. First of all, I will give you examples, then I will go with retention, inversion. Okay. All right. CH3. CH2Cl. What are the byproducts? SO2 and HCl. SO2 and HCl. Okay. Next. CH3, CH2OH. PCl5. PCl5. Tell me what are the products? Guess the products. CH3, CH2, Cl plus. Tell me. See the flow chart. POCl3 and HCl. POCl3 and HCl. Clear? Next, C2H5OH plus PCl3 plus PCl3. Tell me the products. See the flow chart and tell me what we will get. C2H5Cl plus H3PO3. How many chlorines are present here? Here how many chlorine atoms are present? 3. So I am writing 3 here. Okay, clear? 3 chlorines are balanced or not? Then how many alkyl groups we have? 3 into C2H5. So I am writing 3 here. So that is the balancing. Just have a look at that balancing, but not a mandatory. Clear? But the main products are very important. Clear? All of you. Are you getting? Are you following everyone? Right. Now let us understand what is retention, what is inversion. Okay? Right. I am taking one optically active alkyl halide. Optically active alkyl halide. Optically active alcohol. This is optically active. Why? Because this is chiral center. This is chiral center. It is surrounded by 4 different groups, right? Right. Let us consider its configuration is R. Its configuration is R. You know RS nomenclature. R configuration, S configuration in the stereochemistry chapter. This chiral center configuration is R, rectus, sinistus. Are you getting? Right. Now, I am treating this alcohol with SOCl2, plain SOCl2. Here I am treating this with SOCl2 and pyridine. Now look at this. You tell me the difference between these two products. This is Cl and OH is common. Methyl is common. What is the difference between these? Tell me, anybody? What is the difference between these? This is wedge line. In the reactant, OH is on the wedge line. In the product, Cl also on the wedge line. Here, in the product, Cl is on the dash line. OH is on the thick line or wedge line. See, the configuration of carbon in the product is R only. In the reactant, configuration is R. Here also configuration is R. So this is called as retention. Retention means no change in the configuration. Here, see, configuration is changed. Yes. Reversed. Inversion in the configuration. Clear? So when you use SOCl2 pyridine, what you will get? Inverted product formation takes place. Clear, all of you? Got it? Next, keep reading. Lucas test, most important. Lucas test. What are the mark? We wanted to copy. You write here inversion and retention. Shall we go to next method? Other students, are you following? Others, Ayesha, Bhakti. Yeah. Sorry. I wrote reverse. Detention and immersion. Please correct it. Okay. Next, very important first test you are learning. Okay, after our organic. Okay, after starting organic, you are learning first test. Okay, all tests are very important. Clear? Name reaction tests, identification tests. Lucas test. Lucas test. Lucas test. See, in organic chemistry, the advantage is you are learning about one test or one reagent. Clear? That can be utilized in the 2 lessons. You are learning only one test or learning about one reagent. You can utilize the test or reagent in 2 lessons. That is the advantage. Clear? The same Lucas test will come in the alcohols chapter also. Clear? There we can skip. Clear? We can skip. So learning here perfectly, we can skip. Right? Okay. Well, first of all, I'll tell you. I'll give the introduction. What is the use of Lucas test? All of you look at this. Let us consider these two are the test tubes. This is one test tube and this is one test tube, right? I am giving 2 alcohols to you. One is 1 degree alcohol, another one is other degree, means 2 degree or 3 degree. Different degree alcohols I have given to you, okay? But I didn't say which degree alcohol. You have to find. I am giving 2 test tubes to you. You have to find the degree of the alcohols. You can use any test, any reagent in the lab. Clear? That is the task. Right? How to identify both alcohols are colorless only. Both will give the same smell also. Then how can we find which degree alcohol? This is 2 degree or 1 degree. This is 1 degree or 3 degree or 2 degree. How can we find? By using some tests. Okay, Lucas test. Lucas test is used to differentiate primary, secondary, tertiary alcohols. Clear? Distinguishing test. Distinguishing means differentiating which is primary alcohol, which is secondary alcohol. Clear? So what we will do, we will take the Lucas reagent and we will add to the alcohol samples. Right? Based on the result, we will decide the degree. This is 1 degree or 2 degree, like that. What we have to do, very simple thing, we have to add Lucas reagent to the given samples. Based on the results, we will decide. Clear? Right. That is about the test introduction. Lucas test is primarily used to distinguish alcohols 1 degree, 2 degree, 3 degree. Laboratory reagent used for the distinguishing of alcohols, because all alcohols are colorless only. By seeing with the naked eye, we cannot say this is 1 degree, this is 2 degree, 3 degree. That's why we use the reagents. Clear? Right. Lucas test. A reagent used in the test is called as Lucas reagent. Lucas reagent. See, let us abbreviate this as LR. Lucas reagent LR. Anhydrous ZnCl2 zinc chloride plus HCl is called as Lucas reagent. Lucas reagent. Right? Lucas reagent. Let us see the test details. I am taking one alcohol in a test tube, another sample in another test tube, and another one in another test tube. Right? I don't know the degree, just I am taking the samples, 3 samples, right? I am adding Lucas reagent to each sample, LR. Lucas reagent to each sample. Okay. Right. These are alcohols, these 3, right? After adding Lucas reagent, see what happened. In one test tube, I got a white precipitate, turbidity or precipitate, PPT, precipitate, or also called as turbidity, a solid deposit, at bottom, white turbidity in 1 to 2 minutes. Time is very, very important. Previously questions came on the time only. Clear? All of you, time is very, very important. So when I add Lucas reagent to one sample, I got turbidity, white color precipitate, okay, within 1 to 2 minutes, within 1 to 2 minutes only. Clear? Next, another test tube which is having alcohol also produced turbidity, that also given turbidity, white precipitate, but within 5 to 10 minutes. See the time difference, 1 to 2 minutes, 5 to 10 minutes means instantaneously. This is called instantaneously, produced turbidity instantaneously, produced precipitate or turbidity within 5 to 10 minutes. And another sample gives no reaction with the third sample, right? Okay. What we did one experiment. We took samples, 3 samples of alcohols, and we added Lucas reagent. Then what is the result? One sample given turbidity instantaneously, other sample of alcohol given turbidity within 5 to 10 minutes, and third sample didn't give any turbidity, no reaction. See, the alcohol which gives turbidity within 1 to 2 minutes is called as 3-degree alcohol. This is 3-degree. The alcohol which gives turbidity within 5 to 10 minutes is called as 2-degree alcohol. And the alcohol which do not gives any turbidity is 1-degree alcohol. 1-degree alcohol, very, very important. 3-degree alcohols produce turbidity instantaneously in the Lucas test. 2-degree alcohol produce turbidity within 5 to 10 minutes, and 1-degree alcohols do not produce any turbidity. Clear, all of you? Right, now what is the relation between alcohols preparation and this alcohols test, distinguishing test? Clear? Right. I'll ask you one question. You got turbidity, right? Yes or no? You got turbidity or not? Turbidity, right? What is the name of this turbidity? Means alkyl halide or alcohol or carboxylic acid. What is this turbidity? It belongs to what? Actually, you took alcohol, right? You got one new product. What is that new product? I am asking. Turbidity means new product, right? What is that turbidity? That turbidity is nothing but alkyl halide only. We are preparing alkyl halides, right? We are preparing alkyl halides. So this turbidity is nothing but alkyl halide only. This turbidity is 3-degree alkyl halide. This is 3-degree RX. 3-degree RX. Here this turbidity is 2-degree alkyl halide. 2-degree alkyl halide. So very, very important question in the Lucas test. Which alkyl halide is produced instantaneously? Answer that. Which alkyl halide is produced instantaneously in the Lucas test? Tell me. Which is produced in the 1 to 2 minutes? Which alkyl halide is produced in the 1 to 2 minutes? Right. Any confusion in this? Bhakti, Aisha? Which alkyl halide is produced instantaneously? 3-degree alkyl halide. Which alkyl halide is produced within 5 to 10 minutes? 2-degree alkyl halide. Which alkyl halide cannot be prepared in the Lucas test? Which alkyl halide cannot be produced? Tell me. Can we produce primary alkyl halide? No. We cannot produce primary alkyl halide. Got it now? Everyone? Right. Now I'll give you one question. Sorry. Bhakti, are you following? Take screenshot and write later. Right. Let us see the question. Let us see one question. The alcohol which produce alkyl halide instantaneously in the Lucas test. The Lucas test is the alcohol which produce alkyl halide instantaneously in the Lucas test is first option isopropyl alcohol, second one 2-butanol, third one 2-methyl 2-butanol, D ethanol. Answer this question. What is the answer? What is the answer? Option C. Yes. Isopropyl alcohol. See the structure of isopropyl alcohol. This is isopropyl alcohol. Isopropyl alcohol is 2 degree. This is 2 degree. 2 degree alcohols do not give alkyl halide instantaneously. Within 5 to 10 minutes they give. 2-butanol. 2-butanol structure is this is 2-butanol. 2-butanol is 2 degree. Next 2-methyl 2-butanol. 2-methyl 2-butanol. This is 2-methyl 2-butanol. This is 3 degree alcohol. 3 degree alcohols produce alkyl halide instantaneously in the Lucas test. Got it, all of you? Okay. Ayesha? Sad. Did you get this? Yeah. Obed, are you there in the class? Obed. Adiba, any doubt in this? Right. Are you comfortable? Are you getting sleep? Anybody? This is preparation from alcohols. Preparation of alkyl halides from alcohols. Next preparation from carboxylic acids. Preparation from carboxylic acids. Preparation from carboxylic acids. From carboxylic acids, we have two methods. First one, Hans-Dicker reaction. Second one is HVZ reaction. Hans-Dicker reaction and HVZ reaction. First one, Hans-Dicker reaction. Hans-Dicker reaction. See the definition: silver salt of carboxylic acids. Silver salt of carboxylic acids when treated with bromine in the presence of CCl4, produce alkyl bromides. This is called Hans-Dicker reaction. Silver salt of carboxylic acids when treated with bromine in the presence of CCl4 produce alkyl bromides. Okay. Vaishnavi, are you there in the class? Vaishnavi? Are you following Vaishnavi? Right. Let us see the general reaction. Silver salt of carboxylic acids, RCOOAg. Silver salt of carboxylic acids when treated with bromine in the presence of CCl4, carbon tetrachloride, produce alkyl bromides, and byproduct is AgBr and CO2. AgBr and carbon dioxide. No need to learn the byproduct. The main product is important. Alkyl bromide. I'll tell you a shortcut trick how to write the product. Very easy. First of all, I'll give the shortcut trick. After that, we will go with the mechanism. Clear? First, we should write the product. Clear? Marks oriented. Then we will go with the mechanism also. Right. In rare cases, mechanism is useful when paper is very tough. Okay, like JEE Mains model questions or depend on the mechanism only. Right. For NEET level, I'll give you one shortcut trick. Clear? Right. Take screenshot. Right. See the trick. How to write the product? Trick. Remove or cut COOAg and add bromine to R part, R group. Cut COOAg, cut entire COOAg and attach bromine. Look at this, RCOOAG Br2 CCl4. What I said, what is the shortcut mechanism? Cut COOAg and attach bromine. Let us take one example, then you can understand easily. I am taking CH3COOAg, silver salt of carboxylic acid, silver acetate, we can call it as silver acetate, sodium, like sodium acetate, silver acetate, Br2CCl4. What is the shortcut trick? Cut COOAg and remove total COOAg and attach Br to it. So CH3Br, whatever it may be the compound, cut COOAg and attach Br. Now I'm asking one question. In the second example, in example 2, how many carbons are present on the left side? Number of carbons in the reactant side. Tell me, how many carbons are present here? How many carbons? Two. Here, how many carbons are present? Number of carbons? One carbon. Very, very valid point, important point. In Hans-Dicker reaction, number of carbons will decrease in the product. In Hans-Dicker reaction, number of carbons will decrease in the product side. Very, very important. Clear? If you have n carbons, here you have n minus 1 carbon atoms. N carbons gives rise to n minus 1 carbons. Very important, right? Are you following, everybody? Bhakti, Aisha. So remember the trick. This, in organic say, tricks will be very, very helpful to you instead of the main mechanism, right? In some cases, based on the mechanism only, we'll write the product, but mostly tricks will helpful to you. In Hanslicker reaction, you have to remember what I have to do. I have to cut COOH and I have to attach Br, right? Most of the reactions have tricks. Clear? I'll give that, no problem. Next example. Take screenshot if you wanted to write. Can you give the product for this? What is the name of the product? What is the name of the product? Tell me. What is the name of the product? Cut COOH. Bromocyclohexane. Bromocyclohexane. This is not benzene ring. Don't say aryl. Bromocyclohexane. Bromocyclohexane. Cut COOH. Cut total COOH. In the place of COOH, attach Br. Attach Br. Bromocyclohexane. Simple trick. Clear, everybody? Srijan, are you following? Bhakti, is everything okay? Aisha, you? Aisha. Vaishnavi? Vaishnavi. Sadh. Sadh. Sadh, are you there? Sadh. Right. See the mechanism. Mechanism of Hunsaker reaction. This is optional. This is optional. But if you wanted to prepare for JEE mains level, then you can learn. For NEET level, I already completed how to answer. Clear? Right. This is optional only. Clear? I hope you understood. If you wanted to prepare for JEE mains level, then learn this. Easy only, right? Within 5 minutes, we can close it. RCOOAG. RCOOAG. This is considered as a step 1. Reacts with the Br2. Then one Br replaces Ag. This Ag comes out and attach with another Br. Are you getting the point? Like this. Okay. Then what you will get? RCOO. OBr, because Br is coming. And this Ag combines with another Br and eliminated as AgBr. Okay. First step is clear for everyone. Right. In the second step, I am taking this as it is. RC double bond OBr. Now observe carefully, everyone. I kept two yellow dots in this bond. Yellow dots represent electrons. See, oxygen size is smaller. And bromine is larger, bigger one. There is no proper bonding, stable bonding between oxygen and bromine. Okay, due to size differences, this bond cleaves in the homolytic fashion. Br will get its electron and oxygen will get its electron. See, we have two electrons, right? in the a single bond. One electron belongs to bromine, one electron belongs to oxygen. So this bond cleaves homolytically. Homolytically means each bonded atom will get one electron. Clear? Right. Leads to the formation of radicals or C double bond O. Just a second, sorry. O dot. Oxygen is getting one electron and Br dot and Br dot. Highlight this Br dot. Br dot. Bromine free radical is formed. Clear? Is this step okay? What is the driving force here? Why I am cleaving homolytically? What I said? Size differences. Oxygen size is smaller, bromine size is bigger. So there is no proper bonding between them. That's why this bond is cleaving homolytically. Clear, everybody? Right. Next I am taking this. I am taking this. Right. Here oxygen is having one electron. I represented that electron as it easily. And look at this. R means methyl, ethyl or any group. And this is carbonyl carbon. Again I am representing two yellow dots. That yellow dots represent electrons. Again here homolytic cleavage takes place. Why? I'll tell you what is the reason for that. Okay, this bond between carbonyl carbon and R undergo homolytic cleavage. Homolytic cleavage means this carbonyl carbon will get one electron and R will get one electron. R dot, put in the box, represent it separately. Right, next C double bond O dot. This carbon is getting single electron and oxygen also having dot. Right. Now these two dots join together to form stable carbon dioxide. That is the driving force here. Why this bond is undergoing homolytically? If this bond undergoes homolytic cleavage, this carbon will get one single dot. That single dot and this single dot both participate in the bond and form stable carbon dioxide. That is the driving force. Clear? Due to formation of stable molecule, this is undergoing homolytic cleavage. Clear? Right. Next, observe these boxes, pink color boxes. R dot and Br dot both will combined. Due to formation of stable CO2, stable carbon dioxide. That is the driving force. RBr, our required product. Clear? We wrote this only by using shortcut method. Right? Got it, all of you? About the mechanism. Now I'll ask you one question. In Hansa-Dicker reaction, which reaction intermediate is formed? In Hansa-Dicker reaction, which reaction intermediate is formed? R dot means free radical or carbocation? Free radical. That is very important and worthy point. Very important and worthy point. You can mention that, okay, in your notes. Note in Hansa-Dicker reaction, free radical intermediate is formed. And CO2 also liberated. I given that byproducts at the beginning only. Halogen radical is formed. Carbon free radical is formed. Clear? Right. This is about the mechanism. Got it? Srijan and Sadh. Bhakti, Vaishnavi. Bhakti, are you there or not? Nidra vastunda? Are you getting sleep? Anybody? Okay, no. Generally asking. Others, are you getting sleep? Others, are you comfortable? Everybody. Aisha, are you there? Sadh. Right. Next. Adiba. Adiba, are you getting sleep? Srijan, you, what about you? Right. Next, this is about Hans-Dicker reaction. Now keep adding HVZ reaction. HVZ. Next, preparation from carboxylic acids. HVZ reaction. HVZ reaction. Full form of HVZ. Hell, Wohlhard, Jelinski reaction. Hell, Wohlhard, Jelinski reaction. HVZ. Hell, Wohlhard, Jelinski reaction. It is preferentially used for the alpha halogenation. Alpha halogenation. Mention that point. Alpha halogenation. Alpha halogenation. I'll complete this and I'll close. Okay? Right. Just 5 minutes, 5 to 10 minutes topic. HVZ reaction. Hell, Wohlhard, Jelinski reaction. HVZ. Carboxylic acid is the functional group. Functional group. The carbon which is next to functional group is called as alpha carbon. This is alpha carbon, right? If we attach halogen, if we do the halogenation in the alpha position, that is called alpha halogenation. Alpha halogenation. In HVZ reaction, halogen is attached to alpha position. Clear? Alpha carbon. But condition is if alpha hydrogens are present. Condition. See how many alpha hydrogens are present? Alpha carbon and how many? 2 alpha hydrogens are present. 2 alpha. That is the condition for HVZ reaction. This is also question. Which of the following do not undergo HVZ reaction? The one without alpha hydrogens. Alpha hydrogen means see this one only. The carbon which is next to functional group is alpha carbon and hydrogen which is on the alpha carbon is called alpha hydrogen. How many alpha hydrogens we have? 2 alpha hydrogens we have. Clear? Right. See, when I use red phosphorus plus Cl2, this is the reagent of HVZ, red phosphorus plus Cl2 or red phosphorus plus Br2. Okay. Halogen is introduced. Halogen is introduced into alpha positions. Okay, this is alpha position. Halogen is substituted in the alpha position. No need to think about this hydrogen. Clear? No need to think about byproduct. Okay, questions won't come on this byproduct. Right. Let us take one example. Very easy. Writing the product is very easy. Remove hydrogen from the alpha position and attach chlorine. Attach chlorine. See this example. CH3CH2 COOH, propanoic acid, red phosphorus plus Cl2. Attach Cl in the alpha position. So CH3 CHCl COH. What is its name? 1, 2, 3. 2-chloropropanoic acid. 2-chloropropanoic acid. Got it? Did you get this? All of you? Take screenshot. Next example. Cl2 plus red phosphorus. Cl2 plus red phosphorus. Now I am giving the numbering. Tell me, in which position halogen will come? First position. First position is the alpha position, right? So in the alpha position, halogen will come. Halogen will come. Right? Right. Condition for the reaction. Condition for HVZ reaction. Presence of at least one alpha hydrogen. Presence of at least one alpha hydrogen. If alpha hydrogen is not present, that do not undergo HVZ reaction. That carboxylic acid do not undergo HVZ reaction. For example, I am giving this carboxylic acid. What is its name? 2,2-dimethyl propanoic acid. 2,2-dimethyl propanoic acid. Is there any alpha hydrogen? Alpha carbon is present. Alpha carbon is present. But is there any hydrogen on it? Is there any hydrogen? No. Clear? So it do not undergo HVZ reaction. Do not undergo HVZ reaction. Got it? Do not undergo HVZ. Clear? We will continue tomorrow. Right? Tell me. I am not getting Adima, what you are asking. Who said to read NCRT? Don't read NCRT for organic. See, you follow class notes and our questions. Okay?